And look at that. We are in the last section of Chapter 9, Claims about Paired Data. So this is basically, there's going to be a before and after situation, and perhaps some type of experiment was done. The experiment here, people take a 2-week memory improvement class. So the brain is a muscle. The more you work it out, the stronger it gets. That's what these people did. They went to a 2-week memory improvement class. So they would test their memory before, test their memory after, and they can do this with they show them 50 pictures and then say, okay, what was the first picture, the second picture, the third picture? Maybe 50 is too much. Maybe they just start with 10 pictures and see how many they could remember before taking the class and after taking the class. So once you have their scores for each person, so before they took the class, maybe they could remember 5 things. After they take the class, they could remember 10 things. So then you would subtract 10 minus 5 is 5. They improved by 5. So we're trying to see how much they improved by. Then we'll take those differences and put them in the calculator and find the mean and standard deviation. So a little bit of new notation, because we're talking about the differences, then we use D for the difference, and then D bar is going to be the average difference. And then instead of using just S, it's S sub D for the standard deviation of the differences. The number of people or the number of pairs is going to be N, and then the claim is going to be about the mean for everybody or the mean difference for everybody. And if you like to do the formula, then it's the good old T formula that we used in Chapter 8. So that would be the score minus the mean in the claim divided by standard deviation, and that's divided by the square root of N also. And of course, because we're using the T, that means we're going to use table A3 where degrees of freedom is N minus 1. So then for an actual example, so people join this weight loss program, they're weighed at the beginning, and then they want to see after 4 weeks, where are they? So they weigh them again after 4 weeks. So this person went from 170 pounds, 4 weeks later, they weighed 166. So they lost 4 pounds. This person lost 1 pound, so I'm going to be subtracting and subtracting, and I'll make a new column right here. Oh yeah, also test the claim the program is effective. So here's the differences. Now notice that this person was 0 because they stayed the same. So the program did not seem to be effective for them. This person actually gained a pound, so the program was not effective for them. But when there's positive numbers like a 4, then it worked for this person because they lost 4 pounds. This person, well, that's success. They lost 1 pound, etc. So to be effective means that these numbers over here are positive. So that's going to be the claim. When the average difference is positive, that is a success. H1 will be the same, meaning it's a right tail test, and H sub O always says equals. So then what I did is just took these numbers right here, the differences, put them in a list, and found the mean and the standard deviation, just like we started doing way back in Chapter 2. Okay, now I need a new page, so I'm just going to put the same information that I just had, and then look up the critical value in table A3. Since N is 12, that means degrees of freedom is 11, so use this row right here. And it's a right tail, so we're only using one tail, and I'm going to use 95% confidence. That means the alpha equals 0.05. So the magical rectangle says the critical value is 1.796. So now I can take that page away and draw the picture. So there's the nice bell-shaped curve and the critical value 1.796. Now if you do the formula, it's going to be D bar, so 5.33, minus the number from the claim, 0, divide by standard deviation, and divide by square root of 12. That's going to be 4.263. And this definitely goes past 1.796. That means, yes, we did prove something. Instead of using the formula, you could use the calculator. Go to t-test, type in the data, and then the calculator says you should have gotten 4.2626. Once I round that, it's 4.263. And if you're using the p-value method, this p-value is so small, you can reject h sub o. Because your chances of being wrong if you reject h sub o would be a 0.13%. Very small chance of being wrong. So reject h sub o, and that means that the claim is true. So the weight loss program actually does work. So these people on average are losing a little over 5 pounds in 4 weeks. So 5 pounds a month doesn't sound like a lot, but then again, if you lose just a little bit of weight consistently over a long period of time, you're much more likely to keep the weight off. Hey, what was that? Okay, now we're ready for the next one. So here's the memory improvement class. So they're tested before and after the class to see how many of the 50 random pictures they can remember. And for this, we're going to use a confidence interval. So out of the 50 items, the first person could remember 34. After the class, they could remember 37. So they actually improved by 3. This person improved by 1. This person improved by 5. But notice that when I subtract straight across, I get a -3 because of the way these original numbers were set up. So subtracting straight across gives me negatives when people actually improve. This person stayed the same, so that's not a negative. So actually negatives are good news here. So again, I just put these numbers in list 1 and found the mean and standard deviation. There's the mean and standard deviation. And then I just went to t-interval, and because the data was already there, then I just hit enter, and the calculator says that they are improving by anywhere from 5 items to 1.348 items. So that means that they are definitely improving. So these two sides agree that yes, it's going to be negative. And in this case, negative is actually a good thing because that means that they're improving. So yes, this class actually does help people improve their memory.